Okay, so I'm sorry, I just can't seem to get all of this video done. This is the last thing, I promise, the very last thing that we have to do in section P4. I ran out of time just a minute ago talking about the absolute value problems. So let's look at one or two examples of absolute value at work. Here's an example. Suppose I ask you to solve this absolute value problem. X minus 2 minus 3 is equal to 0. Now, absolute value involves distance, and so you always have two possibilities, a positive distance and a negative distance. The first thing we're going to do is we're going to isolate our variable, which in this case is the absolute value of x minus 2, so we're going to put the 3 on the other side. So fix it so that the only thing left on one side is the absolute value symbol. And then the easiest way to talk about this, absolute value of anything is both positive and negative. So what I would say is, copy what's inside the bracket and set it equal to exactly what was on the other side. X minus 2 is equal to 3. And then also copy it exactly as it was and set it equal to the inverse, which is negative 3. Now this solution is x is equal to, we're going to add 2 and we're going to get x is equal to 5. And this problem, if we add 2 to both sides, is going to be equal to negative 1. So this is the best way to handle an absolute value equation. Now they can get more complicated than that. I'm going to get you one here. Hang on just a second. Suppose we have something like that. Let's do one more of these. Absolute value of x squared minus 3x equals negative 4x plus 6. Now this is a much more complicated equation, but let's do the exact same thing we talked about. Copy what's in the bars and set it equal to exactly what was on the other side. And at the same time, copy what is in the bars and set it equal to the opposite, the inverse, which is positive 4x minus 6. And let's see what happens. First of all, this is quadratic, so we know we're going to get everything over to the left side, set it equal to 0. So this becomes x squared plus x minus 6 equals 0. So this comes over as positive, this comes over as negative, this is our equation. This one will become x squared minus 7x plus 6 is equal to 0. Now, since both of those are quadratics, think back on the way we can solve quadratic equations. Most of us like to factor, so let's try that. This one would factor x plus 3 times x minus 2 is equal to 0. X is equal to negative 3, x is equal to positive 2. Over here, again, most of us like to factor. X factors of 6 that give 7 are 6 and 1, both are negative. And so x is equal to 6, x is equal to 1. Now there are 4 possible solutions to this problem, and we would need to check and see which of these, if any, will work. This is the idea of extraneous solutions. So I'm going to come right down here and check. Let's check negative 3. Here's the check. Negative 3 squared is 9 plus 9, absolute value, should equal 12 plus 6. This is 18, this is 18. Negative 3 is a fine solution. Now let's check 2. 2 squared is 4 minus 6, which is negative 2, equals, and the absolute value of negative 2 is 2, equals negative 8 plus 6 is negative 2. Okay, absolute value of negative 2 is 2 equals negative 2. This is false. So that means this is an extraneous solution. All right, continuing to check. I'm going to push this up just a little bit. Let's check 6, and we would have 36 minus 18 is equal to negative 24 plus 6. This is the absolute value of 18, which is 18, is equal to, and this is negative 18. And once again, that is false, so that is not a root. And finally, let's check 1. That's 1 minus 3, which is negative 2. The absolute value of that is 2, is equal to negative 4 plus 6 is 2. That one is true. This is a solution. So our problem that started out with 4 possible solutions only ended up with 2. This is the idea of extraneous solutions. Negative 3 and negative 1 would be, negative 3 and positive 1 would be our only solutions. All right, that's all for that section finally. So tune in just a minute to see video P5. Thanks for listening.